All right, trigonometry students who are in pre-calculus, we are going to be moving on to graphing trig functions again. We've done it once, but we are now going to be translating them. Translating it actually means to move around left and right, up and down. This is why we're talking about phase shifts. Horizontal and vertical. And I'm calling it Lecture 11 because the homework for it is Homework 11. Okay, so let's get to translating some things here. So let me write in here Lecture 11, Graphing Translated Trig Functions. Okay, now translations do mean when you take your basic parent graph, there's a curve, sine curve that I just drew, excuse me, and I move it. So what you might be looking at is the graph is down here. But it still is going to cross that axis over there. You're just going to see it differently. But this point here that was at 0, 0 now moved. It moved to the right. You just as well could have had the same picture. Move up. So this is what we're going to talk about. Author starts out by saying, just like any other function that we've done, trigonometric functions can be translated. And we can move the functions to the left. That means we're talking about a horizontal change. And they're going to represent that the H stands for a horizontal shift. And they're going to use K to represent a vertical shift. So we look at those three examples here. There's my sine curve, and there is a horizontal shift. There is a vertical shift. Now your vertical shift is the easiest to decide. It's simply exactly what you see. If you see a +2, you know it went up 2. If you see a -5, you know it went down 5. But the H is that tricky one that whatever we see here is always the opposite of what you're seeing, what you're thinking. And so we're going to look at some examples. This is just like the parabolas, just like the polynomials that we've done before. So plus K shifts means up K units. A negative K shifts means the graph shifts down K units. Now, if you see a plus H, a positive 4, let's say, then we know the function, the trig function, shifts, wait for it, not to the right, but left K. Did he use the wrong? Oh, yes, he's using the H. That's right, horizontal. H units. And minus H, the opposite, would be shifting to the right H units. So let's look at this here. We're just going to decide what translations are going on. Well, good news. I don't see anything with the angle that is connected to the cosine. Since it wasn't in a parenthesis, the only thing that gets the angle of cosine is the x. So x is by itself. So there's not going to be any horizontal shifting with number 1. You are going to have a vertical shift because k is equal to 2. So the function is going to shift up 2 units. Let's move on to number 2. Tangent functions can move left, right, up, and down as well. The tangent of x, this goes together. Tangent of x. That means x is the only thing that is connected to tangent. That means there is no h component. Just the -1, which means shift down 1 unit. Number 3. Haha, you see the difference between not having an h component and having one? This pi over 2 is definitely not a shifting up or down because it's inside the parenthesis. It is part of the argument for the sine function. So this number stands for a plus h component. And when you see plus, we know it shifted left pi over 2 units. The whole picture shifts left to number 4. Same thing. The argument is x minus pi. So the minus pi is the minus of the h component. So horizontally, put out a t there, shift to the right 3 units. Now let's see here. Midline. Midline is the middle of the graph horizontally. And so shifting a graph vertically will create a new midline, a new horizontal axis called the midline. That's what it's creating, a midline. Normally, what we were doing in the other lesson was all our trig functions. Midline was at y equals to 0 because our cosine was there, our sine was there, our cosine function was there, something like that. And the midline, between the upper and the lower, was at y equals to 0. But when we shift our graph up or down, the midline has to move just as well, okay? This is the difference. This is the reference line to how a graph oscillates. Oscillates means goes up, goes down, goes up, goes down. And the equation for the midline, I think what he wants to say is that y equals to k would be the equation of your midline. You know, the other day when we were just graphing y equals sine of x, Well, that's not much of a mystery. We knew that the graph did something like this, and it continued, of course, and it also went that way. We know for a fact that the midline is y equals to 0. Well, because outside of this sign of x was a plus 0. So my k was equal to 0. So we know the midline was at the 0. Now when we're shifting up and down, like this one, the midline changed. Whatever this k number was became my new midline. Okay? That's all that means. And so we're looking here. Here is exactly what I was just talking about. Y equals to k. K was equal to 0 plus 0. So there's your midline. In this case, the second function of f, I wish they'd have called it another letter. It's obvious that it shifted up 4. So let's count up 4 and see what happens. 1, 2, 3, 4. And I graph that line here. That became the midline. It's not a secret. Okay. We're going to be doing some new vocabulary. We've talked about amplitude. We already know that amplitude was how high and how low the function is going. Okay. We know that from the midline, we go up a distances, a units, and down a units. So the amplitude is basically in this problem, we can identify right here, is right here. Here's my amplitude. Period was how long, how many times I can go. I'll make that sound better. How long does it take for a full cycle? And we knew from the past that if this is my amplitude, actually I made it a big A, is what I always did. He uses a small a. Go back up, or he or she. Look at, there's your amplitude right there. Small a, according to her. So, okay, I'll keep it consistent. I'll try not to, we'll say small a. And remember what we did for period. We took 2 pi divided by the b. Go back up to the original equations up here. B is right here. Now, the author chose to pull the b out of the x. We had in the past, we had y equals 2 cosine of 3x. But if you think about it, I could easily just put the x like that. And still you got the same 3x. We still know b was a 3. So that's why b, but now that I have something else inside, it's always better to have b pulled out. If you didn't, you would have to distribute the b with both of those pieces, and you'd have a bx plus or minus a bk. And so that makes it harder to understand, not bk, bh. That makes it harder to understand what the horizontal change was. So it's just better to think of the b as being out. I wish somebody would have taught me that when I was younger. So 2 pi divided by b. Now phase shift would be how I'm moving left and right. Vertical shift would be how I'm moving up and down. New equation for midline, y equals to whatever k is. So let's tear this one apart. Let's see. Yeah, they got a lot going on here. As I said, a is 3/2. Now look at the k. I don't see anything with a k. So b must be a 1. H, I don't see anything else in the sine function. So h must be 0. And this number here is my k. So k is 3, and it's a positive 3. So I know exactly what's happening. Okay? So what I want us to do is realize that I'm going to go up 3, and I'm going to go to the right, 0. I don't change left or right. I could have said left, 0, but because there's nothing, if h is 0, it doesn't go left or right. So this is not going to be too hard. My midline is going to be k, so right here I'm going to put midline will be 3. And there is no phase shift. There is no phase shift, so I can just write none. When he says phase shift, he's talking about horizontal. Now my vertical shift was up 3. My amplitude was 3/2. And my period is 2 pi divided by 1, which is 2 pi. So what I'm going to do is I'm going to start here at the 0, just like any other sine curve was, and realize that I have to finish this cycle in 2 pi. So that bad boy is here. And we would like to have 2 cycles if possible. So I'm also going to go left 2 pi from the 0. Since I didn't shift left or right, I'm going to go here and graph 2 pictures. Now, what do I do for 2 pictures? I divide my region up into 4 vertical lines. I'm going to use a different color here. So I'm going to try to count here and see. Let's see. Between 0 and 2 pi, half that distance is pi. So there's one of my dividers. Between 0 and pi, to calculate that, I do pi minus 0 divided by 2 is pi over 2. So the value is pi over 2. It's exactly in the middle. And I hope you see this, that this is exactly in the middle. To go between pi and 2 pi, you can see it. You can see it, you know. But what is that value here? To calculate that value here, let me calculate the ones I have. I had this as a 2 pi. This was given me as pi. We've calculated this as pi over 2. So it'd be nice to know what this one is. Think about it. If we know this distance is pi over 2, this distance here, we know this distance is pi over 2. That means this distance is pi over 2. So pi, this gets kind of complicated for some kids. But to figure out that number, I take pi and I add it to pi over 2. Now, get a common denominator. Pi is the same thing as 2 pi over 2. So 2 pi plus 1 pi is 3 pi. Keep the denominator of 2. So this number is 3 pi over 2. My very best students label all of those numbers, at least for one cycle. The other cycle, I'm not going to list them all. Just one time is fine. So here's what I'm going to do. Here's how I do sine. We know this didn't shift left or right, so sine has to start here. Then it has to go up because it was a positive sign. So where is it going to go all the way up to? All the way up to where I divided the first quartile. Well, you know what I haven't done? I messed one thing up. I should have finished doing it wrong, because then I could have given you extra credit for somebody who saw it. We know the midline changed 3. So I can't start here at 0. I literally got to go up to 1, 2, 3, and I got to make a new midline. Okay, so there's my new midline. So I'm going to have to start here. And I got to go up because it's a positive sign. If you look at it, it was a positive 3/2. And what haven't I done? I haven't decided how 3/2 acts. How high am I going to go? Well, the amplitude is 3/2, so it's 1.5. I have to go up to the top here. And then down 1.5 will be how far down it goes. So let me do it here. I'm starting here. Got to go up to the 3/2, make a dot. It's going to come down to the midline, put a dot. The next divisor that I have is here. So down. And then it has, did I go enough? No, yeah, 2. Then it has to go, hope I've got it right. Let's see, I think I didn't go far enough. Don't do what I did. Make your dots first. I have a dot here, a dot here. I have a dot here. Then I have a dot down here. And then it starts dot here where it ended. There. See, do your dots first. So up, down, round it off. There's your perfect sine curve with the amplitude of 3/2 that way and then down 3/2 this way. That's that distance here. And then this went from 0 to 2 pi. And it keeps on going. So let's just do a fast touch up here. If it's going to go from here, 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 here are my lines. So the middle of this, and the author didn't put all of the numbers, I believe, let's see, 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4. So I have this midline right here. Half of that goes here. The other half goes here. So to finish this picture, has to come down to the midline. I'm sorry, to the minimum. Go up to the midline. Go up to the next quartile. Boom. Here's the other part. And let's answer the question. Well, I already answered all those. Let's move on to number 6. It's tangent. Number 6 is graphing tangent. And all I see with it is a phase shift, they call it, a horizontal shift, left pi over 2. Now, when we last talked about tangent, we didn't do a whole lot of tangent. Is we realized that, by the way, this does not have any k. A k is 0, so it doesn't, nothing's shifting up or down. So as I recall, we had, don't write this down, but our tangent did something like this. It was centered at 0, 0. It had 2 asymptotes on one on each side where it went up, up, up from the bottom left because it's a positive tangent. Up, 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 crossed over, up, 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 like that. That would be my parent of my tangent. Now, as long as I put the dotted lines in the right place. So let me do that. The parent function had a period of, if you recall, the period, tau, was pi divided by b. And in this case, there's no number in front of the x. There's just a 1 out here. So let me write that out here. We know this one has a period of simply just a pi. Okay, pi. The amplitude, there's none for tangent. In this phase shift, it had none. Oh, yes, it does. I'm sorry. I lied. Let me look at it. I said it goes left pi over 2. So its phase shift was left pi over 2. Vertical shift had none. And the median used to be y equals to 0. It still is. Y equals to 0. So graphing, whoop, let me just spin you around. Graphing the original tangent. The original tangent, if you recalled, went from pi over 2 to pi over 2. Here was pi, right here. Half of that went from here to here. And as I recall, that period is pi because the period is always going to be pi divided by b. And if y was just the tangent of x, There's no phase shift in there. There's no B. It's a 1. So we had this graph that had a dot here at 0, 0, went up from the bottom like this. That's my parent. Now the new problem here, this one here, we need to shift to the left pi over 2. So it's going to be exactly the same picture, except this dot has to left pi over 2, which is here. That means the period still has to be pi. So from here to here, pi over 2 distance. This is a pi over 2. That's another pi over 2. That distance here. So here's where my asymptotes are going to go. Not where the original black one is, because that was the parent. And I'm going to do the exact same thing. I'm going to say, here's where it's got to go up from the bottom, up, 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 up. And remember, it goes down forever. So up, 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 wrap it up, twist it over, go towards the new asymptote. There it is. This one here, the black, is not part of my answer. That was my parent function. So now I got to go pi over 2 a period again from this asymptote to another pi over 2. Well, there it is. So here it goes. It's got to go. I need the middle of that. Looks like here. Oh, no, I'm really wrong. I'm wrong. Got to go. Whoop. This was the first pi. Here's the second pi. So my next cycle is centered there. The black one was the original parent again. That's the original parent. I just did that just to see what's happening. But this one has to have an asymptote at the 0, like I said. Then I got to go over half a pi, pi over 2 here. There's the other asymptote. So here goes. Up from the bottom, cross over, there it goes. So it becomes very easy. Another full pi takes me all the way to pi over 2 if I choose to keep going. The middle of that is right here. Here it goes. Up, 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 up there. Look at that. All those beautiful pictures. A lot of cycles. One, let me erase the one that doesn't count because I don't want to confuse anybody who's actually trying to. The parent, this one, was just there for perspective. Okay? Let's talk about well, I already have all the answers. Amplitude, it never has an amplitude. It did have a period. The period is always pi divided by b. And in this case, b was 1, so that was a pi. We did shift left pi over 2. Okay? Next. Whoop. Now it's a cosine graph with everything under the sun. Everything under the sun. It has an amplitude of 4. It has the b value, which is used for my period of pi over 2. It has an h of a positive pi, meaning it's going to the right, and it has a k of a positive 1. It doesn't hurt to write everything that we see. Amplitude is A, is 4. Period is 2 pi over b. In this case, it's 2 pi divided by 2/3. And we talked about how to do that math in our head. 2 times the 3 divided by the 2. That becomes 6 pi divided by 2, or 3 pi. We have a minus pi, so that's my h. So h tells me left, no, I'm tricking you, right pi. And k is telling me up 1. So I've done a lot of information here. I can fill in this part right here. Amplitude, we said, is 4. Period, we did the work. We said the period is, what did I say? 3 pi. Wow. 3 pi. The horizontal phase shift, that's left or right. We said the horizontal phase shift was right pi. So it's right pi. Vertical phase shift, did it shift? Yes, it shifted up 1. Y has to be equal to k is my midline. What's my k? It's a 1. So y equals to 1 is my midline. So graphing this one, I guess I'm going to make sure I find my midline. It's a 1. So I don't care about my x-axis anymore. I care about this line right here. That's the center of my graph vertically. And where does it going to start? If the cosine usually started at 0, this one has to shift to the right pi. So find right pi. There's my new axes right here. Those are the lines I'm going to pretend exist. And I'm not even going to look at my x and y axis of the original. Matter of fact, I wish I could somehow magically just, I wonder if I could change it to white. That'd be kind of cool. Do I have a white color? I don't think so. Let's see. There is a white color. Hold on here. Watch this. Oh, cool. I'm pretending that that's kind of cool. Okay. I kind of like that, but let me go back to my yellow color. Okay. So there's my new lines that I care about. That was kind of I've never done that before. Never used the color white. Matter of fact, when I had crayons, we always threw those away. Yeah, what do you do with a white crayon? Nothing. All right. So my cosine has to start, if it's a positive cosine, it is, it's a positive 4, has to start at the top, the maximum value. And if this blue line is where it started and my amplitude is 4, then I need to count 4 up. 1, 2, 3, 4. There is my maximum. I got to count 4 down. 1, 2, 3, 4. There is my minimum from my midline. Now, where is my starting place? It used to be at 0. It used to be y equals to 0, but it's not now. Because I'm phase shifting, I already wrote it. I'm here, right here at pi. This is pi. And now my period, we said, is 3 pi. So it takes 3 pi to get this thing graphed. The bad news is I'm sitting at pi. And if I go here, that's only going to be 2 pi. So let me go 3 pi to the left. Pi was a distance of 1, 2, 3, 4 tick marks. 1, 2, 3, 4. There's a pi. 1, 2, 3. Let's see, I lose track of counting. 1, 2, 3, 4. 1, 2, 3, 4. There's another pi. There's 2. 1, 2, 3, 4. There's another pi. So here is where I'm going to start it, and then here is where I'm going to end it since I don't have room to go the other way. So I'm going to start one cycle left of my starting place of pi, which is fine. You can go left one cycle. You can go to the right one cycle. Cosine, let me divide that region up into 4. Okay, that's going to be a little harder count them again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So half of that is 6. 1, 2, 3, 4, 5, 6. So I need to know that this is a middle. And then half of that is 3. 1, 2, 3. So here's my 1/4 of it. And then, let's see. 1, 2, 1, 2, 3. Here's another one. And then 1, 2, 3 takes me back to here. So how did I do this in the last problem? Only place the dots. Cosine has to start at the high. Has to come down, cross the midline, go down to the very minimum. Has to go back up, midline, then it has to end up at the very top. So truthfully, the picture is actually curving like this. There. Now let's go ahead and just try to finish up filling this grid here. We know that 1, 2, 3 was another very important place. 1, 2, 3 was another important place. That just gave me where it went from the top to here to here. There, that's about the best I could do. There's my graph of a shifted cosine. Another tangent. Now, this tangent has an amplitude of 2, or it says 2. But remember, there's no amplitude, there's no highest value. All that means it's going to be stretched vertically. However, I do notice right here a left pi over 4 from the original, and I notice a down 3 from the original. And reminding you again, oh, actually, I do, this is not my amplitude. I lied. My amplitude is 1. This 2 was my B. Silly me, silly me. I bet somebody was out there yelling. So my period, my tau, will be pi divided by 2. That means from asymptote to asymptote, that distance is pi over 2. Not very big, pi over 2. So let me do, kind of hard. This is really hard to do a tangent on this graph with so much going on here. Let me ignore my x and y axes and realize that my midline changes to down 3. So I'm going to use my yellow. This 1, 2, 3 is where my midline goes. I used to start it at 0. I used to start my tangent here with a dot right here, but not this time. So I have to realize that the new starting vertical line will be to the left pi over 4. So let's see, left, this is left pi. This is pi over 2. This is pi over 4, half of pi over 2. There's my new starting line. So if I wanted to play that game again and say, I don't need that x and y axis, I could change that to white again just to prove a point to you. I don't want to get rid of the numbers, and I don't really want to mess up. Okay, it's good enough. I think I've done enough damage on that to let you realize that I really care about where the yellow lines are. Okay. So now, go to dark black. I wish I need more yellow line going down just because. I'll borrow some here. We know the dot is going to be here. And it's still a positive, so it's going to go from the bottom up. But I need to measure off what pi over 2 is? Well, pi over 2, if you recall, there was a distance of 1, was 2 tick marks. 2 tick marks is pi over 2. That means that's how long my period is. It's pi over 2. So I've got to go 1 tick mark, since it was 2 tick marks, is pi over 2. 1 tick mark to the right, 1 tick mark to the left will tell me where my asymptotes are going. Boom, 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 boom. There. So that's how wide my cycle is. And it's a positive tangent, so I'm going to start from the bottom, go up, curve in, and there it is. It's super skinny. If I do another one, I need to go and measure off 2 tick marks from this asymptote. 1, 2. There it is. So another dot will go in the middle right here. So up and down. 2 tick marks. Another asymptote. Go in the middle of those. There you go. Up from here. There it is. I need you to do a couple more than what I do. That's how I can prove that you're watching the video, not just copying what I've done, but you're actually thinking. My amplitude, really there's none. My period we calculated was what did we say it was? Pi over 2. My phase shift was right. No, was it right or left? I don't remember. It was left. The original one, I went left, pi over 4. Vertical shift was down 3. And my midline was y equals to k, which was 3, which is how far I went down from the 0. Okay, stare at that and drool. The writer filled it up, so you probably should do 1 or 2 more pictures. All right. A sine curve with an amplitude of 3. B is a 4. My H tells me to go to the right, pi over 2. And my K is a negative 2, which means down 2. So let me do my math here. My period is 2 pi divided by 4, which is pi over 2. So it takes from vertical asymptotes a distance of pi over 2. And so let me do blue as my new pretend axes. Well, let me go right over here. Amplitude was a 3, which just means it's going to be skinny. Period was pi over 2, if I did the math right. My horizontal phase shift said I'm going to the right. Did I say right? Yes, pi over 2. Right, pi over 2. My vertical shift is supposed to be down 2. Midline, y equals a negative 2. So let me draw my axes. We don't even use the amplitude, really. Down 2 from the 0. So here I'll do a really dark blue line here. That's my new pretend x-axis, if you want to think about it. That's my y-axis, I mean. No, my x-axis. My new pretend y-axis will be shifting to the right pi over 2. Right pi over 2 would be half of between pi, so there I am. There's my new pretend y-axis. So going from starting there will obviously be where my first dot goes. And my period is pi over 2. So the distance between pi over 2, see, that distance here is pi over 2 right here. Half that distance is 1 tick mark. So I got to go 1 tick mark over, and 1 tick mark over. That gives me a period of pi over 2 starting here. Here I go again, starting from the bottom, going up, curve in, go up, stay, don't touch the asymptote. So to go to the next dot, I got to start at my asymptote and count 2 tick marks, 1, 2. And that dot goes in the middle of them. And here it goes. Oop, oop. 1, 2. Middle dot. That one's going to go up that way. That one's going to go down. To the left, 2 tick marks from this dotted line. 1, 2. Middle dot. To the right and to the left. There's 4 cycles. You do a couple more. Finish up this side here. Do one more over here. Do one more over here. Do 2 more over here to prove that you're paying attention. Okay. Another one. Another cosine graph. Okay. There's a 1 in front. So amplitude is a 1. My B is a 2. My H is a positive 3 pi over 4, which means to the left 3 pi over 4. And my K is a 4, positive, so it means up 4. So my new axes, well, let me do the math over here on the side here. The only thing I haven't done, I didn't do the period. My period is 2 pi divided by the 2, which is pi. So the whole picture can be done with pi radians. All right, let me say I go up 4. So my new x-axis, 1, 2, 3, 4, is right here. That's my new x-axis. That's my new midline. You write that out. Y equals to 4. Up 4. Okay. My new x-axis, since I have to go left 3 pi over 4, well, here is 1 pi over 4. No, it's not. So here's, let's see, 3 pi over 4. That's 3/4 of pi. That would be here. Because here's pi. Here's 1/4, 2/4, 1/4, 2/4, 3/4, 4/4. So here's my new x-axis. I'm only looking at the green as my new, why do I say x? That's the y-axis because it's vertical. That's my x-axis because it's horizontal. So I'm just pretending, because there's not even enough room to do this cosine graph because my amplitude is 2. So I have to go up 2. So 1, 2 means the high is going to go is up here, and the low 1, 2 is down here. And I know for a fact that the period is pi, so the whole picture ends in pi. So even if I start it right here at the very top, right here, there's the top, because that was my midline right here. There's the top. This cosine is going to finish in pi radians. Well, this is 3/4 of a pi all the way to here. This is another 1/4 pi. That whole picture is going to end here. So I got to figure out how to divide that up into 4. 1, 2. It already isn't divided by 4. Okay, so let's do it here. And remember, I'm only going to go between these two lines. I'm sorry. These are the 3 lines. Okay. So I start at the top, midline here. The bottom of it is the next quarter, which should be here. Okay, hold on. Yes, it's the bottom. That's the bottom green line. Then it has to go back up to the next one, and then up to here. There it is. Wow, it's kind of confusing. Ooh, there's one. So let's say 1, 2, 3, 1, 4 more lines. 1, 2, 3, 4. Whoop, it's not drawing again. 1, 2, 3, 4 will be another. Let me do black again. I don't know why I went black. 1, 2, 3, 4. And then 1, 2, 3, 4. Okay, I can get 2 more pictures here. And then you can do this one here. You can finish that up, but let me finish this one. There's the 3 lines again. There's the 2 lines. The goalpost has to come down to the midline, the minimum, up to the midline, back up to the max, down to, keep going, midline, minimum, down here, and then it goes back up. Oh, there it goes. Here's my picture. Ooh. And you're going to finish that one up to prove that you're watching your notes. Okay? And we did put everything in. No, we didn't. We didn't even address it. Amplitude was 1. Period we figured out was pi, right? Which was 4 tick marks. Phase shift was to the left, 3 pi over 4. All right. Last one here. Tangent. Do I really want to do another tangent one? Oh, they're so much fun. Yeah, right. Amplitude is 2. Not that it matters. But my B is a half, so my period is pi divided by a half, which flip that 1/2 makes it 2 pi. Ooh, that's very stretched out, very stretched out. My H is a 1, which means up 1. That's my K, I'm sorry. My H is a positive pi, which means left pi. So I'm gonna do red this time. Axes will be in red. I used to start at 0, 0, but not in this case because I'm shifting all over the place. So I'm gonna go up 1 as my new x-axis, and then I'm shifting to the left pi, so that'll be a negative pi right here. There's my new y-axis. Therefore, my first dot starts here. And my period is 2 pi. Half of that is pi, so I have to go 1 pi to the right, 1 pi to the left. That takes me to here. This is where my first set of vertical asymptotes go. And so I'm going to start coming up from the bottom, curve over, boom. And I'm going to do one more. From that asymptote, I need to go 2 pi, 1, 2, right here. Here it is. There's my other asymptote. The middle would be at pi, right here. So I go, boom, there it is. I only have 2 pictures there. Let's record our information. Amplitude, actually there's none. I think I wrote on the other tangent, I may have wrote a number, but we really don't talk about it. It doesn't have a max up. So period we said was 2 pi. Period was 2 pi. Phase shift was left, left, pi. And the vertical shift was up 1. So my midline is y equals to 1.